So here, to derive this, as you know that in a capacitor, one plate consists of positive charge and the another plate consists of negative charge. Okay, let us see how the energy is stored in the charge capacitor. So now it is said that the energy stored in the charge capacitor is the total work done in charging the capacitor to a given potential by transferring charges from one plate to another plate of the capacitor. Okay, how is the capacitor charged? By sending the charge from one plate to another plate. Okay, so we say that when the charge is sent from one plate to another plate, we say that the capacitor is charging. Okay, or you can say that that is what the energy stored in the charge capacitor in the form of potential. Okay, so now coming to the derivation, it is said that consider an intermediate situation of charging the capacitor. Okay, so let Q be the total charge on capacitor at the intermediate situation and V dash be the potential difference between the two plates of capacitor, so that V dash is equal to Q by C. So as you know that the potential between the capacitor plate is written as V is equal to Q by C, or C is equal to Q by V, right? So instead of V, we have taken V dash as the potential difference between the two plates of the capacitor. So hence we are going to write that as V dash is equal to Q divided by C. So the next, the small amount of work done in transferring an additional charge dq from the negative plate to the positive plate is given by dw is equal to V dash dq. Okay, so see here, the amount of work done, okay, the amount of work done in transferring a small charge. Okay, let us take dq is the small charge. Okay, so let us try to calculate what is the work done in transferring a small charge, that is dq, from one plate to another plate, that is from negative plate to positive plate. So how you are going to calculate? As you know that, what is, how you are going to define the work done? Work done is nothing but equal to V into Q, right? So this is the equation we have come across. So V is equal to W by Q, right? So W is equal to V into Q. So since you know that we have taken a small charge, so that is dq we have taken, so the work done will also be the smaller one. Okay, so hence we are going to write that as dw is equal to v dq. Okay, so that is what we have written here. Okay, you can see this, dw is equal to v dash dq is equal to, we have substituted the value of v dash, that is q by c into dq. Okay, okay, so the next is nothing but, this is the small work done in order to move a small charge from negative plate to positive plate. Okay, so now we need to calculate what is the work done, okay, in moving all the charges from one plate to another plate. That is, we need to calculate the total work done. Okay, total work done in transferring the charge from 0 to capital Q. Okay, 0 is nothing but from initial stage to maximum. Okay, where the capacitor is charged to maximum state, so that Q denotes the maximum state. Okay, so hence what we are going to do is, as you know that, we will integrate this equation. Okay, that is dw is equal to q divided by c dq. So integration of dw is nothing but it is w itself. So and next is q by c. Okay, we have written that q by c into dq, and we have taken a limit is from 0 to capital Q, that is from initial state to maximum state. Okay, so hence we have taken that 1 by c outside. So 1 by c is taken outside, integral of 0 to capital Q into small q dq. Okay, so as you know that, what is the integration of x square? What is the integration of x square dx? X square dx is nothing but written as x square by 2 plus c. Okay, integration of x square dx is nothing but equal to x square by 2 plus c. That is what we have written there. Okay, so 1 by c into q square by 2 to the limit of 0 to q. So now 1 by c it is written in the same way. So in the place of small q we have substituted the value of capital Q, that is we are substituting the upper limit minus lower limit, right? So what is the upper limit? Upper limit is capital Q, lower limit is 0. So hence that step comes out to be as 1 by c into capital Q square divided by 2 minus 0, and hence that can be written as W is equal to Q square divided by 2c. Okay, so this work is stored as the electrostatic potential energy U in the capacitor. So whatever the work done we have done to move the entire charge from one plate to another plate itself will be stored in the form of potential energy. Okay, the work done will be stored in the form of potential energy. So hence we are going to replace W by U. So U is equal to Q square by 2c. Okay, so this is the expression for energy stored in the charged capacitor. Okay, so as you know that these are the different forms of potential energy of a charge capacitor. Okay, potential energy can also be written as q squared divided by 2c, or half into qv, or half cv square. Okay, these are the different forms. So I think you are aware of this different forms, right? So how did you get that? Substituting the, taking the equation of this, c is equal to q by v, right? So if you substitute the value of c in the place of that q square divided by 2c, you are going to get the different forms. Similarly, it is half cv square. Okay, this is how we are going to express the potential energy of a charge capacitor in different ways. Okay, so just go through for a few minutes. Yes, have you understood? Any doubts regarding that sixth question? Okay, fine. So the seventh question, we have already gone through that in the 3 marks main itself. Okay, that is capacitance of two capacitors connected in series, and we have also gone through about this expression for capacitance of two capacitors connected in parallel. Okay, so hence we have just finished the revision of this electric potential and capacitance. Okay, both 2 mark, 3 mark and 5 mark questions we have gone through. Okay, so this is regarding the electric potential and capacitance. Okay, so next is regarding the next chapter, that is current electricity. Okay, so I'll just share the another file. So that is 2 mark, 3 marks. We'll start with that. Okay, so see you. We will start with the 20th question. Okay, 20 from 20th question it is current electricity chapter. So we will go through with that. So it is said that define drift velocity of conduction electrons. Mention the expression for drift velocity. Okay, so the answer for that comes out to be as the average velocity with which conduction electrons in a conductor gets drifted against applied electric field is called drift velocity. So as you know that when the conductor has been connected to a battery, so what happens, the electrons, that is the free electrons which is present inside the conductor, what happens is it moves in a direction opposite to that of the direction of electric field. Okay, so the velocity of that electrons which drift in a direction opposite to that of electric field is called as the drift velocity. Okay, so the expression for the drift velocity is given by v subscript d is equal to minus e into capital E divided by m into tau. Okay, so where E is the uniform electric field in the conductor, small e is the charge of electron, and m is the mass of electron, and tau is the relaxation time. Okay, so this is regarding the drift velocity of conduction electrons and the expression for the drift velocity. Okay, so many times they have asked this question in your examination. Okay, so the next is deduce the expression for drift velocity of conduction electrons. Okay, so this is just a definition and we have expressed the final expression of drift velocity. Now we need to derive that expression for drift velocity. Okay, so let us see. It goes like this: in conductor the free electrons are in random thermal motion. The average thermal velocity of all such electrons in a conductor is zero. So as you know that the electrons, that is the free electrons inside the conductor at the room temperature itself, it will be moving in a random direction. Okay, when you take the average of that all the electrons which is moving in a random direction, the average thermal velocity of such electrons comes out to be as 0. Okay, so hence we are going to mathematically write that as u average is equal to 0. Okay, which is denoted by equation 1. So next, what happens when you connect a battery, that is when the electric field is applied. So what happens, the electrons drift or accelerate in a direction opposite to that of uh, applied electric field. Okay, so at that case, the acceleration of that is expressed as, from the Newton's second law we know that F is equal to m into a, right? So making use of that itself, the acceleration of that electrons, okay, can be written as a is equal to F by m. Okay, as you know that F is nothing but what, force experienced, right? So force experienced by the charge, we are going to write that as F is equal to E into Q, right? Sorry, E is equal to F by Q, we are going to write. Okay, so this is the equation, that E is equal to F by Q. So F is equal to Q into E. So this is the force experienced by the charge, right? So since we are dealing with the electrons, so what happens, we are going to replace that Q by E. Okay, and that negative sign denotes that the electrons are drifting in a direction opposite to that of applied electric field. So hence that is considered as equation 2 there. Okay, so next it is explained, I mean they have explained the terms there. So minus E is nothing but charge of the electron and m is the mass of electron. Okay, and next is u subscript I is velocity of ith electron immediately after the previous collision, and t is nothing but the time lapse after the previous collision. So next, as we know that from the equation v is equal to u plus at, okay, we are going to make use of that. So that is expressed as vi is equal to ui plus ati. Okay, that is v subscript I is equal to u subscript I plus a t subscript I. Okay, so that is nothing but equal to u subscript I minus e into e divided by m into t subscript I. Okay, just we have substituted the value of a there. So next it is said that the average velocity of all n free electrons in a time interval t is, that is u subscript I minus e into e divided by m into ti average, that is the average they have taken. So hence you know that from the equation 1, the value of u subscript I, that is average, is nothing but equal to 0. So hence the left out terms will be v subscript d is equal to 0 minus e into e divided by m into tau. So that is expressed as v subscript d is equal to minus e into e divided by m into tau. So this is the expression for drift velocity. Okay, so that v average itself we have taken as v subscript d, we have replaced that v subscript d. Okay, v average by v subscript d. Okay, so this is the expression for drift velocity, and even this is a uh, question which they keep asking in your examination. Okay, go through once. Yes, shall we move to the next question? Have you followed? Okay. So here coming to the next, that is state and explain Ohm's law. So even this is an important question. So it is said that the current through a conductor is directly proportional to the potential difference across the ends of the conductor provided the temperature and other physical conditions remains the same. As you know that if you take a conductor, okay, any conductor, so the current flowing through that conductor is directly proportional to the potential difference across the ends of the conductor. Okay, so that means that as the potential difference increases, current also increases. Okay, and it is said that provided the temperature and other physical conditions remains the same. Okay, the temperature should remain constant. Okay, only in that case. So mathematically I is proportional to V, or we can write V is proportional to I. Okay, so since it is a proportionality term, in order to write in terms of equal sign, we need to add some constant there, that is nothing but R. So V is equal to Ri or IR. So R is called as the resistance of the conductor. Okay, so the next is regarding the limitations of Ohm's law. Okay, so limitations of Ohm's law is nothing but, as you know that it is only applicable for a conductor where the temperature should remain same. Okay, it is not applicable for at very low temperature and at very high temperature. And next is nothing but Ohm's law is not applicable for non-ohmic devices such as semiconductor, transistors, discharge tube. Okay, so Ohm's law is only applicable for ohmic devices. Okay, so non-ohmic devices doesn't obey the Ohm's law. So these are the limitations of Ohm's law. Okay, so the next is nothing but it is regarding the explain the dependence of resistance on the dimensions of a conductor. Okay, on what factors this resistor depends. Okay, so the resistance of a conductor directly depends upon the length of the conductor. Okay, that is R is directly proportional to small l. And next is inversely proportional to the area of cross section, that is R is proportional to 1 by A, that is inversely, right? So hence clubbing those two, you can write R is proportional to L by A. Okay, so replacing that proportionality term by equal term, you can write R is equal to rho into L by A, where rho is called a constant, that is called as the resistivity of the material of the conductor. Okay, so this is regarding the factors on which the resistance of a conductor depends. Okay, and this question they are going to ask in your viva, as I previously said in the uh, classes. Okay, so what is the difference between this resistance and resistivity? Resistance is nothing but it is the opposition offered by the conductor. What is resistivity? It is numerically equal to the resistance of a conductor provided that to unit area and unit length. Okay, you need to add that unit area and unit length for this resistivity. So that is the difference between this resistance and resistivity. Okay, just go through once. Okay, fine students, we are left out with 2 minutes. Okay, the rest of the questions starting from 25th. Okay, so that is resistors in series combination. Okay, series and parallel. So we will go through in the next class. Okay, so please go through these questions. Okay, so it is the questions which is framed according to your syllabus. Okay, so go through it. In case if you have any doubts, you can ask in the beginning of the class itself. Okay, anyway I have sent the this file to your WhatsApp group, right? Class WhatsApp group, so you can just go through. In case if you have any doubts regarding any question, you can get it clarified. Okay, okay students, we will continue in the next class.